Alright, so basically the change of base rule is log base A of B is just equal to log B over log A. Okay, now you can choose any base there, so let's put a little x as that represents any base. The best base to actually choose is either a base 10 or when you could also use a base E. So on your calculator, a base N is just the LOG button. That will be a base 10. So that equals log 7 base 10 over log base 10 of 5. And then in your calculator, you just have to put log 7 and divide it by or put it over log 5. And you end up with 1.21. That's to 2 decimal places. Now this rule also applies if you've got, something like this. You can use your head. What do I raise 3 to give 1 on 27? The answer is minus 3. Because 3 to the x is 1 on 27. 3 to the x is 1 on 3 to the 3. And when you bring it up to the top, you get minus 3. So the x will equal minus 3. But if you use this calculator method, that would be log 27 and log 3. So if there's nothing written there, it's just the base 10. So it's log of 1 on 27 divided by log 3, and you'll find you'll just get minus 3. And that's your change of base rule. So I'm just going to very quickly just prove that this change of base rule. Okay, so we're going to let that equal x. And I'm going to apply the 7th rule. So log a to the x will equal b. And then what we're going to do is we're going to log both sides of this, and we're going to do it with the base m, for example. So that's log mb. And then what happens is if you bring this x down the front, that would log ma equals log mb. And then x will equal log mb over log ma. This is one of the log rules that we learn, that you can bring the indice down to the front. And so if you look at that, that's basically your change of base rule, because x is equal to both of those things. So up here, x was equal to that, and x is equal to that. So therefore you conclude that log base A of B would be log m of B over log m of A.